Okay, so let's get started. So this afternoon, I will use Excel solver to show how you can actually solve a linear programming problem. And we will be using the potato tomato example that we used in class to show how you solve that. And I think I put the wrong dates here, so it should be 16th. I will correct that after the lab session. So let me actually first show to you to have another look at the linear programming that we're interested. So we have a objective function here, which is trying to maximize the profit. And there were three constraints that need to be met. And finally, we have two decision variables. One is potato, the other is tomato. And that means like that's a number of hectares that the grower or the producer is gonna grow. So for that, based on the linear programming that you set up, you can write the linear programming tableau. And I also explained this in the lecture. So this is basically trying to get the coefficients in this linear programming and put all of those coefficients here in this tableau. And I did put those equation numbers to make sure that we're keep tracking of everything, and that kind of habit will help you make sure that you sometimes don't get confused about the different constraints, especially in your linear programming. And once you have that tableau written down, then you can actually transfer this problem into Excel. And this is what the problem looks like in Excel. And later, a little bit after this this presentation, I will show you. We'll use the actual Excel solver. So this is what it looks like. And this is actually what's behind. So in this one, you'll only see here, for example, numbers. Those numbers are actually calculated by formula that you cannot directly see here. However, I do have them printed here. So those are the stuff that need to be coded, or you need to work on that. But for this example, I already provided all the formulas there, so you don't really need to do this. But later on, if you have another problem, you might need to work on that. And then this is actually what's been solved. So this is what, after you click this solve button in Excel solver, then what the solution might be. And we will also explain what those mean. And if you select or if you ask Excel to report the answer, and you can also generate the answer report. And I will first show you guys how you can solve that, and how you, after you solve it, or while you are solving the problem, how you can ask Excel to generate this report. And then after that, I will explain what those different numbers in this answer report mean. How do you actually read the answer report? So questions before I actually use Excel to start this tutorial. So if we're good, then I'm gonna show you this. So this Excel solver, or not solver, this Excel template, I uploaded it on eClass. So I will probably give you 1 or 2 minutes here to let you download this. And let me know when you're ready. If you already have this downloaded, then I will just start immediately. So it's under this week, under the section for this week on A class. And there's an Excel template there. I think the name is potato, tomato example. Okay, so let's move on. So once you open your open the Excel template, and you can actually say this is what it should be the same for the template you downloaded from eClass and my screen. And what you can do is probably delete those two values there. That's already the solution to this problem that I actually solved it. So maybe you can delete that, and I can show you the steps where you can ask Excel to report those answers. So just a little bit explanation of what's the different components of this spreadsheet. So first is probably these two columns. So those are explanatory. So I just write, for example, this row, it will be decision variables. And those two values in this row are going to be the value for the two decision variables. And the two decision variables, again, is going to be the hectares of potato and hectares of tomato that the grower need to grow. And the next row is objective function coefficients. So here I made it very explicitly that it's coefficient. And the coefficient we explained in the tableau, what's the coefficient. So basically it's a number in front of your decision variables, both in the objective function and in your constraints. So those are the two coefficients in the objective function. And the third, this row here, so this cell, after you solve the problem, it's gonna report the objective function value, or what is the maximum profit in this potato example, potato-tomato example that you're gonna find out. And if you click this one, you can actually say there's a formula there that I have already provided. And I can explain to you a little bit later what that formula means, but let me first explain what different components of this tool are. So this component, this whole component here will be constraints. So this part is objective function, this row is decision variable, and those several rows are the constraints. And I used the same name, land, contract, and labor. So those are the names that we given to the constraints of the linear programming problem. And those are again, the coefficients of the constraints. And once you have your linear programming tableau, then those numbers are easy to find. And here I have a right-hand side. So this is when you have your constraints. There are also several coefficients that is on the right side, right-hand side of your either smaller or equal to or larger or equal to sign. So those are the values there. And there's another 3 cells here. And those are actually when you solve your problem, then those are actually the total. For example, for this constraint, this value means what is the total land that's actually being used. Here, this right-hand side is saying that it has to be less or equal to 10. However, when you actually solve your problem, it may ended up this number maybe 9 or 8 or exactly 10. So this is the number there. You can actually try this, maybe if you can put it one here and one there. So then Here we're growing 1 hectares of potato, 1 hectares of tomato, and here you can see there's 2 hectares of the land that's being used. So the values here in this total are programmed so that it's linked to the value of those 2 cells. And the objective of this template is trying to find out what are the values of those 2 variables that gonna make your objective function the max. So another explanation is here. You can see some cells are shaded and some cells is white without any background color. So I would recommend that you only change the cells that is shaded with the information in the linear programming tableau that you come up with. And don't, at least at the first step, don't try to change those values there, and don't try to change this. So when you're having a different problem, you probably should change those values there. But in this template, I already provided anything. Later on, after we solve this problem, we can try to change some of the values and see how will that change the results. But first is you should provide value for those shaded areas depending on the linear programming you're trying to solve. So with that, let's actually try to solve this problem. And what you should do is actually go to the data here. And I'm not showing it. If you click on that data and then click on the solver, it's not showing on the screen I'm sharing, but I'm clicking the I clicked the solver button. Are you guys able to see my window which popped up saying for solving parameters? I assume you guys, okay, good. So here, this is similar to the previous Excel tool that I have shared. So the objective here is if you click this button, it's this cell. So this is, I put a notation here, the objective function, the maximum profit. So that's the objective. The producer is trying to maximize the value of that cell. So the objective is that cell, this is trying to max. If you have a minimization problem, then you should choose min. So here we're trying to max. By changing variable cells here, those are your decision variables. And it's those 2 cells. So one is the hectare of potatoes, the other is a hectare of tomatoes. And there are several constraints here. So let me put it here. This one is saying that E10 is this one. So this is basically the land that's actually used depending on the value inputted there. So that one need to be smaller than G10, which is 10 here. And then this is associated with the second constraint, and this is associated with the third constraint. So once you have that set up, this one is saying whether you want to constrain that your decision variables are positive. So in our example, we should check this is because we cannot grow negative hectares of potato or tomatoes. So there's no way of doing that. Usually in economics, the decision variables are generally non-negative. So make sure you click that. So here you can click the simplex LP. So LP is linear programming. You can also click this one. The nonlinear algorithm or method can also solve the linear programming method. So it doesn't really matter. You can choose either one. But later on, if your problem is not linear, for example, if you have a quadratic programming, then you shouldn't choose the simplex. You should choose this nonlinear one. But at this moment, it doesn't matter. You can choose either of them. And we get to the point, we can click the solve button. And if we click that, you can see immediately there's already a value provided there, 4.7, 5.3, and there's also value of the objective function. And here you can see solver tells you that it found a solution or constraints and optimality conditions are satisfied. It's very important to check that all the constraints are satisfied, because sometimes there's no solution to a linear programming problem. And if you want to see a report, you should click here, answer. You can click multiple of them, and multiple reports can generate it. But for the moment, let's just say the answer report. Later on, we can also introduce the information from the sensitivity report. But as a first step, let's just focus on the answer reports. And if you click that, then you click OK. So as you notice, so this one is what I already had it before. This one is the one that's just been generated, and you can actually see the time here. So that means it's just been generated. So here, let's first see what happens in this tab or this spreadsheet. So first is it tells you the value of the decision variables. So it tells you that potato is 4.7 and tomato is 5.3. And if you check the value of the decision variables that we solved, use the graph method. I showed this in the lecture, and it should be the same. And this is a value you're looking for. This is the actual profit if you're growing this amount of potato and this amount of tomato. And there's a little bit more information here. This is to tell if you grow this much potato, if you grow this much tomato. This is the land that's actually being used. And you can check it's the same here. And this is the amount of, I think it's tomato that's actually being produced. And as you can see, the constraint is saying that it should produce at least 2 units. However, it produced 5. And here is saying that the labor should be smaller or less than 12 hours, I think, and it's exactly the same. So you can say that some constraints are binding, some are not. And that's what you get from this spreadsheet. And we can actually also look at the report, the answer report, and there's information there. So first, get to here. This is the objective cell, and they also tell you it's max. And this is the cell that was maximized. And if you go back here, you can find it's C5. So this was the cell. And here it was tell you the original value. We didn't provide any value there, but if we provided value, then it will show here. I can show you what this looked like if you provided the original value. And this is the solved maximized profit. So this is the final value. It should be the same as this number here. And these are the variable cells. So these are the decision variables or the activities. And again, these are the original value that was there. We didn't provide anything, so Excel just assumed it's 0. And those two are your answer. And this one we haven't covered by basically saying whether your decision variables are continuous or integer. So here it says continuous. Sometimes if we have integer programming, then we can constrain the decision variables to be an integer. In this problem, we didn't impose that restriction. And finally is a constraint here. So you can first say here whether it's binding or not, as we mentioned that the land was binding, the labor was binding. You can check if you're not sure which constraint it is referring to by clicking the cell here. And the contract here is not binding. So this is a contract here. As you can see, the linear program is saying you need to produce 2. You actually provided 5. And so that's why I said it's not binding. And the slack means you actually provided 3 more. So that's how you read the answer report. Let me actually get rid of this answer reports and also the other answer reports here. Let me show you if I just put a number 2 and 2 here, now what it looked like, the answer reports. So again, I'm gonna use data and I clicked solver, and I don't need to change anything here. And I just need to click solve. I ask for the answer report. Okay, and you can see a new answer report is generated here. So say these are the original values that I provided 2 and 2, and this was the original value here when those 2 cells are 2. So again, you will find that the final value are the same. So this is your maximized profit, and those are the optimized value for the decision variables. So that's basically how you use solver to solve for the linear programming, a very simple linear programming. And as I mentioned, there was a formula here, and there was also a formula for those 3 cells. You can write those formulas differently. So let me first show you an easier way or a more intuitive way of writing this. So here, the objective function is C2. So C2 is the potato value there. Let me actually provide a value there so that it's more straightforward. So this cell is saying that C2 is this 1 times C3. C3 is 3,000. 1 times 3,000 plus D2, which is 2 times D3. So this is 1 times 3,000, 2 times 2,500. And this was the objective function if you go back to the mathematically written down the linear programming problem there. And this cell is also the same as this C2. This is the number of hectares that was used to grow potato, and times C7. So C7 is a coefficient here. So this is basically rewriting your constraints that you provided in your mathematical problem. And you have to be careful about the equality signs here. And also the right-hand side value, you have to provide those. So that's one way of saying this. So this should match the mathematical problem that we provided in the lecture. Another different way is just sum product. So this is basically a different way of writing this equation. And the advantage of this is later on, if you want to include another variable here, you don't need to do anything. You can see here it's already changed. So right now, this cell is calculating this number times this cell, this number times this cell, and this number times this cell. So it makes the change of the linear programming easy. You don't need to do anything. You just insert another column to represent another decision variable here. However, if you're using this version of the formula, and if you want to add another decision variable here, and you can see here this objective function, you need to change it because it's only calculating the value of potato and tomato. It didn't calculate the value from this third decision variable. So that's the difference between those two variables. And it's also the same of this of the constraints here as well. And as you can probably see here, those are also changed. So you only need to put values here, and you don't need to change the formulas there. So that's why I'm providing both of them, but you should use the one that you're comfortable with. And I think that's what I want to share, and also probably a little bit more about the reference of the cells. So you probably noticed that I used $sign in the template, and I'm not gonna go through all those points here, but I want to mention to you that there are absolute reference when you say your cell are like this, and when you say your cell are like this, then it is sorry, this is not absolute. This one is an absolute reference. This is a relative reference. And later on, if you say something like this, that's a mixed cell reference. So there's difference between them, and you should check the difference. And another technique that I want to share with you is that you saw me show how you can show the formulas to you. And there's you can also show this if you know the short key to do that. So let me show you here. So I showed you this is the formula, and I can just by click Control plus this this sign there, and you can say it's go back to the numbers here. And if I click it again, then it's showing you the actual formula. So that's another thing that I want to share with you. And with that, I think I'm done with the tutorial. And what we can do as a practice here is, in the problem we asked that, I think this is tomato. Let me see which one here it is. Yes, this is tomato, because the coefficient for potato is 0. So here, this constraint is saying that you should produce at least 2 units of potato. Let's change this to 6. This constraint to be 6. You have to produce at least 6 units, and see how your results can change. So you should probably try this now, and let me know if you're having any difficulties of doing that. And if you actually have it done, maybe you can share in the chat box what's the answer that you got. Okay, looks like we have an answer here. I actually have this tab here which shows the answer, but let me show you how you can get the answer. So you have to change this 2 to 6, and then after you change that, you click Data and Solver, and you don't need to change anything here actually. So those are actually all kind of the model setup. If you only change the coefficient value, you don't need to change anything here. So we solve it, and we click on OK. And you can see now my values are not 4.7 and 5.3. It becomes 4 and 6. And here it's exactly 27 thousandths here. So that's basically how you use this tool. Later on, we will have more complicated examples. And but this is the basic idea. If you fully understand this example, then even you're having more decision variables or more numbers of constraints, the process is actually the same. It's just a little bit of more work. So I will stop this tutorial for now, and then I will take the specific questions you guys might have. And I have to say that I haven't finished grading the midterm exams. I had some family issues which delayed everything, and I'm really sorry about that. I will try to finish the grading either today or tomorrow. Then after that, I will share with you guys some summary or some summary statistics of the exam. And if I have any comments, I will also provide that.